Good morning and welcome to the LogScope Mobile functionality seminar. In this webinar, we're just going to go through a list of the functionality from how to download LogScope through to some of the basic mapping and cross-section functionality that's available on the iPhone and the iPad. This functionality is also on the Windows version, so you can follow along on the Windows. It's just that the gestures are designed for Windows tablets as opposed to the iPad, iPhone environment. There will be a video of this webinar at the end, and we have Akash Mansour and Bill Arji online as well, and they'll be handling any questions that you may have. So I guess the first thing, I'll get started. To download LogScope on the iPhone or the iPad, you just simply go to the App Store and you select LogScope, type LogScope in, and it will give you the LogScope application there, and you can download it directly and follow all the typical Apple functionality to add the application to your iPhone. Okay, so I'll just close that down. When it's downloaded, it appears as an icon, and mine is in the bottom row, down the bottom here, next to the Apple TV. So to fire up LogScope, you simply tap on it, and it opens up. Now we've added an additional layer of security to this, which is Face ID and also Touch ID. But in lieu of those, you can type in your passcode. So I'm going to do the Face ID. Also at this point, if you've downloaded LogScope for the first time, you will have to enter an email address, your first name, your surname, and a phone number to get an account where the license to use LogScope can be registered against. So I'll just go and get LogScope started up. So I'm just going to hit try Face ID again, and it's going to pick up my Face ID, and I'm presented with the initial menu. And we have wells in a list, and you can have as many wells as you like. I have on my iPad over 1,000 wells there. Certain features that are available here is the edit button allows you to do multiple selections, and as soon as you do multiple selections, you'll see that the menu items on the top change, and you have X section and manage. Manage will allow you to do archive, delete them, duplicate them, or rename them. So you can do that there. You can also do a cross section as soon as you select multiple wells. But I'm going to show how to do a cross section from the map view. Once we exit out of that edit mode, you'll see that there is a map view. If we hit on the map view, you can see all the wells that I've currently got on here shown in a map view. And if I turn this sideways, the map view is in landscape mode, and obviously you have greater real estate, and you can pinch and squeeze, and it automatically shows more wells as the scale increases. And this is a function that is characteristic of both the iPhone, iPad, and Windows environment. It will, as you keep on expanding the scale, it will keep on increasing the number of wells that you can actually see. So I'll go back to the list view. The next function that we have at this level is a filter function. And I've got a filter defined, and you can define map boxes, and you can actually define by name, and you can also define by log. You can then put in a list of wells, and you can use any parameter that is in a well header or a log mnemonic or a formation top. You can use all those things to define the filter as to how it's done. Typically, the quickest way to get data into LogScope is to tap on the file and use the open with functionality, and it will open with LogScope and it will open the data. In addition to that, we have the import functionality, which allows you to go to directories. Here, I'm looking at my iCloud drive and a folder in my iCloud drive called LogScope, where I have a bunch of wells, a bunch of files that LogScope can load, and they are highlighted in bold. Any that it can't load is dimmed out, and you can load LIS, CSV, which is the core example, and LogScope can generate archives of the complete data in a single well or multiple wells, and you can load those as well. So we'll come back to doing this in a minute. So I'll just cancel out of this. And then we have the account, which if we click on that, we have the account settings. You can purchase a subscription from the App Store, and that follows the same protocol as normal in-app purchases in any application. And they are a monthly subscription, and it can be done over a year. You can see what subscriptions you've got active using active subscriptions. You can see the active devices associated with a subscription. And you have the additional functionality there. You can change your password, change your details, and log out of a particular registered account. One final functionality that we put in for corporate clients is the ability to enter an activation code, and you access that by left swiping on your username, and you get the activate button, which allows you to enter a code that we supply. So that's the account. The next button is the settings. Now in the settings, you can play with the preferences. They're self-explanatory. We've got help, and then we've got feedback. You can visit the website, privacy policy, EULA, a variety of other things in there. And then right down the bottom, we've got WITSML, which is kind of the next thing that we're going to. LogScope on the iPhone, the iPad, and Windows allows you to poll a WITSML server and pull data down in real time. So if you have a well drilling, you can actually see that information at any time. The WITSML servers that LogScope is capable of using is the Baker WITSML server, Petrolink, Schlumberger's Interact, any Kongsberg server, and Wellcom, and any other WITSML server that is compliant with the latest WITSML standard. We can access that. So practically what you do is you tap on that particular icon, and it takes you to the next page, which presents you with the option to select a WITSML server. So you tap on that, and then you can add your username and password for all your WITSML servers. And I'll just show you with the Baker one how it looks. So you can swipe left, on that, you can edit, and you can see all the parameters that you put in, and you notice that the server is entered using a HTTPS address, your username, your password, and then there is a test button down the bottom, whereas if you tap on that, it will come back with connection OK if you've got your password right, your username right, and the WITSML parameters are correct. So I'll just cancel out of that. So to access that, I just tap on it, and it takes me into the Maker WITSML server. The next thing I want to do is select a wellbore. So I tap on the wellbore, and it gives me the demo well in there. So I tap on that, and then the WITSML server respects the well sidetrack sort of structure. So it's not being repeated. You have the name of the well twice. I'm going to give the well name a character at the end, so it doesn't sort of mess up with any other. And the next thing you need to do is you need to tell LogScope, I want to look at these logs. So you go to the log mapping, and this is where you tell it which logs that you want to pull in. You can create templates, and those templates can be loaded by simply accessing the template, and you can pull them in. And you can also see that you can save. So if you've already got a bunch of wells, a bunch of curves, an array specified, you can save that as a template, and you can deliver that template to colleagues and to other people. Add array allows you to pull in data that may be stored by the particular service company or vendor that's providing you with the WITSML data as individual curves, and you can stack them together as an array using that particular button. In this case, I'm just going to pull in one curve and show you the functionality and to do that, I use add new, and then we will see the functionality available. So it comes back with this option mapping. I can select all, which selects all the information there. And as you can see, we have everything, including gas curves in there. But the curve that we're going to select to show how this is done is just the gamma ray. So you just tap on the gamma ray curve, it gets a tick, and it's selected, and then we hit done. And then it comes back and it says, okay, I need to put this in a continuous data set. Here's the depth range. Here's the interval spacing I'm going to use. And we just hit done on that, and it's selected. Then you have to keep on hitting done, and you're sort of walking back out, and then it presents that particular well with a triple combo display. So we've got gamma ray, resistivity in a logarithmic, and we've got neutron density. We can add the gamma ray by simply tapping on the gamma ray curve, which highlights it, and we can edit it by just hitting the edit button down the bottom here, and we can select that curve like so, and that curve is added. Okay, it's blank because there's no other information. We can also put the curve in a track, and I do that by simply tapping on the track. Now, LogScope, one of the functionalities that we've built in is anytime something is in focus, it will be highlighted yellow. So the track is highlighted yellow, and that's what's in focus. you can see that the add curve, add array, add image, add tadpole have appeared in the bottom menu bar down the bottom, the blue one down the bottom, and that allows you to select one of those functions. Oops, I just go and tap on that, and I select the curve, and that adds it in, and I've now got that curve added twice, one with a scale of 0 to 100, and the other one with a scale of 0 to 200. So how do I access the WITSML from this particular plot here? This little menu bar down the bottom here, oops, it just slides backwards and forwards, and you can see that the WITSML is at the far right-hand side of that particular menu. So when I've got that in focus, I just tap on that, and then I have the options of setup, or play mode, or update to latest. Setup allows me to go back into the curves that I've defined, and I can maybe grab additional curves, an array. For example, if I have a well where they start with just gamma ray resistivity and then they start producing a density image at some deeper point, I can actually go back and add that information in at the appropriate time. In this case, the play mode allows me to play the data to the plot, and update to latest allows me to update to the last data point that is on the WITSML server. So in this case, I'm just going to do the play mode, and when I do that, you'll see at the top of the screen I have the words play, pause, and exit added there. So in order to start it polling the server, I just hit the play button. Whilst it's doing that, just to explain a couple of other things. When you're in this mode, none of the other functionalities will work. What will work is the refresh button. I can change the scale from feet to meters, or meters to feet, and I can change the scale. So I've got 1:200, or I can change it to 1:500, or 1:6,000. I can also pinch and squeeze to see the scale. I can exit out of LogScope at any time if I have a phone call, and this will continue to keep on working in background and continue to keep on polling the data. So if you have phone calls, or if you're doing other things with your phone, this will quietly sit there chugging away in background. So you don't have to exit. And if I just swipe it off the screen and bring it back, it comes back immediately, and it's still the same place. So I'll just hit exit. So that covers the WITSML data and how you can actually use that information. The next option that I was going to show was how to import a LAS file and a CSV file. Now, obviously, we can open a CSV file directly, or a LAS file directly from the file itself in the Files application that is in iOS 12 and iOS 13. Or we can actually use the import function in LogScope to pull that information in. So I just tap on the import button, and it brings you up the familiar files function, and I'm using an iCloud drive to pull this information in, and I can select a LAS file, which is example.las. So I just simply tap on that particular file, and it comes up and it specifies the file name and whether I want a new one or I can also change it to overwrite by tapping on that, but I'm just going to leave it as new. And then I just hit done. And it loads the data like so. And there is the data. And again, we can pinch and squeeze and look at the data like so. And down here we've got some nice sands with some nice resistivity anomalies showing that these are gas sand and so on. So that's the last file, and the next function is the CSV. To load a CSV file, you can just hit the import button again, and I have a CSV example which is a core example v2, and I can load that. And when you have a CSV file, it may be of one of three sorts. It may be location information, it may be formation top information, or it may be just pure data. In this case, this is pure data. So we tap on that, and we need to set this up. It's saying it's delimited, but it doesn't know how it's delimited. We know it's a delimited file, so we tap on the comma. And we have a preview view down the bottom that allows us to see the data and how it looks. So then up the top, you've got cancel, so you can stop, or you can hit next. I'm going to hit next, and then we have a system whereby you can specify the column that it's going to start at, which is sample number, and the row number it's going to start at, which is designated as sample number 1. And you can see all the values there and so on. And the end is down here. You can actually selectively choose bits and pieces of a CSV file to load. I'm going to load the whole lot. So I go to the next button, and it presents me with a preview, and then I need to give this a project name. So I just tap on that row, and I'm going to say core data v2. It's a discrete data set, so I need to give it a name. So we'll call it RCA because it's conventional, it's routine core analysis. The type is discrete. I could change it to continuous. Now, down the bottom here, you have name, unit, and type. The first is sample number, and I don't particularly want to use this as the dev. So I'm going to change that to text. So it changes it to text. And the next one is actually the depth. So I change that to depth. So I actually have 3 options: text, depth, and real. Real is for digital data. Text is for text data, and so on. And then when I hit done, it loads the data in, but it takes you back to the main menu. And in order to see that well, I just pull down and it refreshes, and I can enter that particular well here. Now I can load the data by simply tapping on the track and then adding the curve. LogScope knows which data is text and which is actual real data. So I can load the porosity, which is pi, and it's helium porosity, like so, and it's plotted there. I can go to the next track and I can add the permeability, which is air, like so, and then I need to change the permeability scale. So I just highlight the permeability, and I want to change that to logarithmic. So I just go to edit, and I hit logarithmic, and I'm going to change this to 0.2 and done, and it plots like so. In the last track, I'm going to put some text, so I just tap on that, and text is treated the same way as curve. It knows what is text, so I'm going to put the direction in, which is just a letter, and it's showing that all these are horizontal, and you can see that the letter is plotted there, and that's how you can handle data like so. So if I tap on the direction and go to edit, I'll just show you some of the things that you can do with the text. So it gives you the margin. You can show the depth label. If we say yes, we can show the depth units in meters or feet. And we can change the color, and we'll change it to red. And then we hit done, and it proportions everything so that you can see the text. Now, one of the things about LogScope is that I'm showing this in vertical, but if I change my phone to horizontal, it automatically updates the display and everything so you can see things horizontally. So that's kind of the loading of data and seeing the data there. So I'll move on to the basic display functionality. And this is the core data that I've actually loaded. And I can go to, I was going to go through the plot functionality, and I can actually move the curves around by tapping on the header of the curve, and I can drag it and drop it wherever I like on the actual plot. I can tap on a curve on a track, as I showed before, and you can add any of the options. Add curve, add array, add image, add tadpole to that. And you can tap on the track and you can actually move it like so. You can move the track wherever you like. So if I tap on another track, I can move that around. And then I can tap on it again and I can move it back to where it's. And I can also copy it. And I can paste it before another track like so. So I can move this track back to where I wish it, and I can select the track and delete it. So you can copy and paste tracks around. The shading is a little bit complicated on the iPhone, and the shading is shown here, and you have a variety of different shadings in the list. And to actually take this particular shading and put it on the plot, for example, if I wanted to take argillaceous crystallutite, I just tap on that, and then I can move it and just simply drop the shading wherever I like on the plot. If I tap on the shading, I get this little box that says track or shading. If I tap on the shading, I can edit it, and the options that I have in the shading is that I can actually have the shading to the track and a percentage of the track, or between curves. The style can be lithology, or I can actually use it for a log attribute, which I'm going to do, and I can choose the log, which in this case I'm going to choose the gamma ray, and I'm going to change the scale to 150. And there we go. And the curve is there, and it's filled in the shading like so. So those are some of the basic functions to do with the plotting of data. Discrete data, which is shown here. I'm just going to go and by the porosity, the curves are selected in exactly the same way. So if I wanted to add, I'll put it here in this track here, add a discrete data curve, I would just simply go and select the curve. I'll just choose direction, and it will plot it with the H symbol in that particular track. So it recognizes what each type of curve is. And that sort of covers kind of the basic sort of functionality with the plot display. The next thing that we're going to move to is the header information. And the header information contains metadata that is important to the evaluation of a petrophysical evaluation, and also the plotting of the well. So down the bottom of the screen, you'll see that there's the word header, data view, plot, cross plot, and deviation plot. We're going to look at the header view, the data view, the plot, and the cross plot view in that order, and cover the various functionality in those. So if I go to the header view captures all the information that is in a LAS file that is in the API header fields that are defined. Of importance are the latitude and longitude information, the permanent datum information, and a parameter called elevation of log 0, and the permanent datum elevation. Those are kind of the important parameters in here to fill in. Obviously, the well name is important, as are the other fields. In fact, all this information is important, and you should make the effort to fill out as much information as you can. LogScope will load that information directly from DLIS files, LAS files, or list files, if it exists in the files. Across the top, you have the plus symbol, which allows you to add fields that may not exist. And the view allows you to change the view to the run view. And the run view allows you to look at the runs within the well. The important parameters are the first reading, because that is the value that is used to match the bottom hole temperature for a particular run to, and how it calculates the temperature gradient. The information can be displayed in either feet or meters, and it's stored. You've got the bit size, which is important for the log analysis. We have the density, which can again be displayed in pounds per gallon or in grams per cc or whatever you're using. Then we've got the mud resistivity properties, which are incredibly important for the log analysis, and filling those in is important. And then we get down to the bottom where we have the bottom hole temperature. You can display those in degrees Fahrenheit, enter them in degrees Fahrenheit or degrees Celsius, degrees Kelvin or degrees Rankine. You can add new runs by adding runs. You can change the logo at the top by using the logo button. You can use the map button to see where the well is in relation to the world. And the preview button allows you to look at the information that's plotted in the header of the plot for the log analysis. So that covers the header, and we're going to move to the data view. So I'll just change this back to the run view, and then I'll go to the data view, and we have the information plotted as a table. Now the first thing is that LogScope stores the data in groups, and if I tap on the groups, we'll see here that we have a default group. Now this is the first regularly sampled data group that is loaded into LogScope, and typically it's the only group if you're loading a LAS file. The RCA is a discrete data group, and what I mean by that is the data is stored as discrete data points, it doesn't have a fixed sort of sample rate. And as you can see, it's got a mixture of text and real values and so on. When you're manipulating the data in any of the equations and so on, LogScope is able to match up different sample rate data that are in different groups and do the computation for you and figure out how it's supposed to handle the data without any interaction from you, the user. That is to say that you can use the core data and the regularly sampled log data to do computations, but those computations will only occur where you have two data sets, the two data in close proximity. You can have the data at different sample rates as well, but in this we've got default, HVR, and LA are regularly sampled data sets, and they are all at 6 inches. So I'll just close that. We're going to move back. Before we move on, some of the things that you can do here is that you can actually change how the data is displayed. Like if we want volume for volume, it displays it as volume for volume. And you can actually edit by just tapping on the curve itself and editing the units and the description and so on. You can change the depth from feet to meters or meters to feet. And that's what's done there. If we go to the group and I do a left swipe, I have the ability to duplicate a group, modify a group, edit a group, and in modify, I have the ability to copy curves and put them in another group. I can also delete curves and rename curves. So there's quite a lot of powerful functionality hidden in there. The import button here allows you to import data For example, we can import the core data, and that's going to let me do it. So we've got text data, and it shows you that the data's there. We can go next, and it gives you the start and the end, and the start here and the end with the parameters that it's loading. And then if we go to this, we have to enter the name of the group. So I'm just going to say RCA2. And it's discrete data. I'm going to change the sample number from depth to text. The first number value, LogScope will tend to guess that that is the depth, where in fact the depth is the second variable, and we can just change that to depth. You can use the toggle switches here to switch off curves that you don't want to import, and then we just hit done, and it loads the data like so. So if we have a look, we've got an RCA2 group down the bottom here, there, and I'm just going to delete that group because I've already got it up there. And that's pretty much how you can import stuff. You can, whoops. You can manage, whoops. So we go to the data view. You can manage the units and so on in a well, and you can actually convert continuous data to discrete data. In the particular example there. So I'm going to go to the plot view, and we go back and we've got the same plot view, and I'm going to talk about the statistics. And the statistics can be achieved by using the HVR, and what you can do is you can output as either CSV or an Excel spreadsheet. I like Excel spreadsheets. You can have curves plotted as histograms, and you can save your layout, including the cutoff parameters, which are at the top here, as a template. So I have a template here called HVR, TOC, UCS, DTC, DTS. So I can grab that, and it will produce histograms of all of those. And if I go to the histograms, you'll see that the UCS, the compressional, and the shear are done by gross interval, which is the total interval, and it's done by actual formation. And I hit done, and I'm going to export that and stuff it in my LogScope directory and save it there. I'll just hit done, and I'll go here, and I've got my HVR there. And if I open that in Excel, you can see that I've got, not only do I have the values, but I've also got a spreadsheet, got histograms for each zone, and all the parameters for the zones are stored here. And you can see the pay, phi E, phi T, all based on the cutoff parameters that we have. So we'll go back to the plot. LogScope has a powerful range of functions available to the user. So if I tap on the functions, you can see that we have linear, logarithmic, you can do unit conversion, You can do the gas wetness ratio. You can set values to missing. You can do interpolation, and you can do smoothing of curves. Basically, when you tap on it, you have an input and an output curve, the default, the depth range, and your parameters down the bottom there. So that's just kind of a basic function. If we go down the bottom, we have the solver function and the scripting. The solver function allows you to put a one-line equation in, and if we tap on that, you just basically type in the one-line equation, and in this case we have the porosity from the density log, and the parameter mapping, which is done automatically, allows you to map the parameters to either an input curve, an output curve, a constant value, or a parameter in the zone parameter file or the zone parameter list associated with the zones that are in this particular well. So the ROMA, I'm using log analysis.ROMA zone parameter. And the parameter is here. And if I tap on that, I can have different parameters for each of the different zones. I can have a constant, or I can have it as an output. So I can actually run this equation, and it will calculate on both the right-hand side as well as the left-hand side of the equation. In this case, it's going to output the porosity, phi, and you just hit run, and it does it very quickly. The next function is the scripting, which is a fully compliant Python engine, and you can put in quite sophisticated Python equations that use both single curves and arrays. You can actually do work with arrays. The logs are selected. The auto mapping button allows it to select the parameters and auto map them in. And then we have the output curves, and then we've created a zone parameter group called HVR, and those are stored here. And we run that by simply tapping on the run, and it runs that equation again very quickly. And just a side note, the power of the iPhone and the iPad is quite extraordinary for its size. The chip inside of these is perhaps more powerful than some of the Windows tablets available. The next thing that we're going to go to is the cross plots. But before we do that, I think I'll just sort of talk a little bit about the zones. The zones are shown by the Show Zones button here. But if we hit Edit, we can add existing zones in by tapping on there. I'll just put one in called Test, and you can move that up and down. You can actually import zones, which typically are formation tops, by using the Import button. And Grid allows you to see all the zones and all the depths in a list there. And if we scroll all the way to the bottom, you'll see the HVR zone down the bottom here. When you insert new zones, it will adopt the parameter of the zone that you're splitting. So here is the HVR zone. So it's HVR, and they're all stored in there. You can edit multi-zones by hitting the multi-edit button, You can change the depths from feet to meters or meters to feet, and so on. So I'm not going to save with that test zone in. I just kind of wanted to show how that was done, and we'll move to the cross plots. So if we go to the cross plots, LogScope remembers the last cross plot that you were in, and if we work our way back up, we'll go to the core example, which is an example plot. You can change the X and the Y axis by tapping on the text on the X axis and the Y axis. For example, we've got the phi A, and we've got the RTA plotted here. You can pinch and squeeze, and the histograms will change scale with as you pinch and squeeze the plot. If we tap on the region button, we can add a region, and we can do such things as regression line, or we can classify those points as a region point, and it will create a flag, or as bad hole, and we can write those points out. And if we go back to the plot, it actually plots those regression lines on the plot. So we'll just exit out of that. The other thing that's available is that you can scroll through by zone on any plot that you create, and you can see the values there. So if I tap and swipe from the left out, I can reveal the log analysis thing. And between the hide and the run, there's the title log analysis. If I tap on that title, I will get the log analysis plot. Well, what's interesting about this is if I've got that plot there, I can actually highlight points by describing an interval there, and if I circle points, it will also highlight in pink where those points exist on the depth index plot. I'll just switch that off. I can load different side plots. So for example, I've got this one here, and the plot will change and show the actual zone, and we are at zone 1, which there's no data, and all will actually show the whole interval. So though that is kind of the basic functionality of the cross plots, and you can actually save the cross plots that you create and use them on other wells and so on. So if we tap on the core example, the next cross plots I'm going to go to are the log analysis. We've also got the geochemistry, but I'm going to go to the log analysis and the density neutron. And this is the density neutron cross plot. It has all the lines on here, and you can move your points about by simply using your finger and moving those points. You can process the data using the process button. We'll talk a little bit more about what can be done with the petrophysics in a moment. But if we go back, we can hide this here, and you can do the same thing. You can change the logs. You can change the clay log. and so on. And you can also pinch and squeeze. And you can scroll through the cross plots one after the other, like so, through the actual cross plots themselves. So that pretty much explains the cross plot functionality. And the next plot that I'm going to talk about is the ternary plots. So I'm going to go to a different well, and if I want to go to a different well, I just tap on the log button. It takes me back to the main menu, and I'm going to choose a well down here called Pelican, which is a well that has uranium, potassium, thorium, and you can see that I've got this ternary plot option here, and I can tap on the ternary plot. I'm going to go to a formation where the ternary plot exists, and in the setup button, bottom left-hand side, I can choose a template, or I can actually set the curves manually myself. And I'm going to choose the photoelectric effect, thorium, potassium, and it will bring up the plot like so. And you can see that I've got the three curves plotted, and with each formation you can see that the character of the formations is quite different. So that's the ternary plots themselves. So if I go back to the plot, I want to go back to the core example, and I want to show the log analysis here. So the petrophysical evaluation of the log analysis is under the log analysis button here. We've also shown that you can access the functionality in the cross plots. But if I tap on the log analysis button, I can specify which of the functions I wish to run. So I can switch things off and on. So if I switch off a bunch of curves here, it will change the input logs and give a list of logs that it requires for the petrophysics. It doesn't need all the input logs because it will do the best job it can at computing what you ask it to do. If I switch on a particular function like porosity, it will actually switch on all the curves that it needs for that, and you can see that the VClay has actually switched on the gamma ray correction. And this goes all the way down. Now, the functionality of rock mechanics, NMR, and shale gas are part of the petrophysical evaluation, and we'll talk about those in a little bit more detail in a moment. But this is basically run by just tapping on the run button. Now the parameters are stored actually in the well by zone, and we've got zone A here, and we've got zone B and zone C. If we tap on the search bar, we can actually select a particular parameter, and we can sort of choose that parameter, and we can actually see all the parameters with RW in them. In addition, LogScope has a way of storing the parameters in what's known as a parameter store by well using the Save button, and you can load the zones from a parameter by using the Load button from the parameter store. So these parameters are here. I think there's close to 150 parameters, but looking at them in a list is not all that helpful. So in the basic log analysis, we recommend that you use the Petrophysical evaluation with or without the plot at the side, and you can set your parameters like so. So I can do things like this and like so, and it will do the evaluation there. I can have the composite plot, which I've got the gamma ray there, which I've got the V clade there. I've got the saturation and so on, and I can actually use that to do my evaluation here. If I go back here, I can hide this, and I can walk through the cross plots with a little bit more real estate than with that plot available. But you can accomplish a log analysis on your iPhone very, very quickly, or on your iPad very quickly. Okay, so if I go back to the plot, I want to talk about the NMR and the rock mechanics. I have a well, so I'm just going to exit out of this, and I'm going to go to set that actually has NMR in it, and I'll just go unload my NMR data set, which is this one here, and you can see the NMR, and this is a gas reservoir. And if I go to the log analysis, I have down here an NMR processor. So if I switch off everything else, this will just take a second. Switching them back on is going to be easy because I can do that quite quickly. And if I go to the logs, you can see that these are the logs that it requires to do the processing. Fundamentally, the only log that's really required is the T2. And then if we go to the parameters, we have the T2 size, the start, the end, and the bin 1 all the way through to the bin 8. We've got the clay cutoff, and we've got the free water cutoff. We've got a scaling parameter that's used for early vintage CMR data and other data to bring the T2 distribution to volume for volume. And then you can actually calculate Timor and Kenmore permeability. The parameters are calculated by typically just hitting the run, and that's how you do it. And if we switch these back on, it will, there's only a few that we have to switch on, and it's switched all those on, and that's how we can process the NMR. And these values are processed using LogScope. The rock mechanics is also part of the log analysis. So rather than switch off all the processes, the rock mechanics processing, the parameters can be accessed by simply tapping on the parameters and you type /p, and then we'll go to the NMR processing, rock mechanics. We have implemented in LogScope the following whoops. So we just get here. We've implemented the following parameters in the rock mechanics. We have the drill fluid density, which is taken from the header information, and we have the clay from the sonic and fluid, and the compaction factor, and the hydrocarbon density. And then the next sort of global parameter is the rock mechanics input parameter. And you can use the final, or you can use the original. The final actually uses the deterministic mineral model that you've created, or the silty shaly sand model that you've created, to work out the contribution of each of the components, be they silt, sand, limestone, dolomite, clay, coal, heavy mineral, feldspar, dirt, and so on, in the actual petrophysical interpretation to calculate the rock mechanics properties. We've also included a pore pressure offset. So if you input a negative or a positive pore pressure value, you can accommodate overpressure and also pressure depletion. We have a whole stress ratio here where you can actually calculate the minimum maximum stress values from the computed density and compressional and shear sonic. We have other parameters that are related to calculating the compressive confined compressive strength and other values in there. And each component in the model has its own value. So this gets run, and the output can be viewed by using the template called rock mechanics. Whoops. I tapped on the wrong one. So I wanted rock mechanics. And there we have all the parameters, including the pore pressure, and we can change that to view the full plot. And you can see the pore pressure here, and the overbalance is plotted there as well. And you have brittleness, you have the UCS, and so on. For the TOC, we've actually developed some cross plots, which are based on the PASI method of calculating TOC, and you just put the baseline point, the RT and DT baseline, on the highest clay, lowest resistivity point on the plot. Oops, I want to go back. And we can do that for the neutron. And you can also do that for the density. And we can view the parameters here. And here like so. And then, so that's basically the plot. And you can export the hydrocarbon volume report like so. And we can load the parameters like so and export it like so. To export plots, and I'm going to go back to a much more colorful plot, we can export that as a PDF, a DLIS file, or any of these other formats. And you can also, by the way, print to a local AirPrint printer that you have there. And by going to a PDF, I'll do that. And we will open in, we'll import it into Adobe Acrobat. And there we have the plot there, like so. It's true scaled to 8.41 inches and so on. So I'll just head back to this. Now, the final things that I wanted to show was the map view and the cross sections. So the map, back to the this view here, and we're going to talk about the map view. If I go to the map view, it will show me where the wells are. There are a few things to sort of discuss about the map view here, is that I can actually impute GeoTIFF and shape files into this data set. And I have a shape file, a GeoTIFF file, which is the SW, or the saturation, for a formation in the Delaware Basin. And I'll just move to where that is. And that is actually input into LogScope there. Now, if we zoom, we can get back to our wells. And the next thing I'm going to look at is that from the map view, one can do a cross section. So if we choose the wells that we want to draw, even if the wells don't appear, they're going to be included. And we just simply draw a shape with our finger around the wells that we want to use for the cross section. And then we pick a projection line, like so. And then we can use the X section to produce a cross section. So this is the cross section. And there they are, like so. And I'll just do I can pick a formation like A, and A, and I can move those up or down like so, and like so. and those will get propagated back to the well. And that's the end of the demonstration.